Good night. Yours truly, Professor Dr. Dolphy Gilpin. I'm here tonight. I'm continuing in the field and subject of chemistry. And tonight I'm going through some introductory organic chemistry, the bonding, SP2, SP3, hybridization. So without further delay, let's get into some organic chemistry and bonding. Okay. Well, I did some organic chemistry at O levels, Cambridge, and a little at A level chemistry. But I anticipated that I would be coming over here in the United States, and so I left the chemistry, the bulk of it, to be done in the United States. But I did do a little at the Cambridge advanced level on the island. So the bulk of the chemistry, as I said, was done in the United States. So I'm back in the United States in terms of the mind and experience in chemistry. And I would be at City College of the City University of New York. And the subject would become 103, 105, and 108. And Professor Morrows was my professor. And he scored me an A in that chemistry there. Pre-medical chemistry, they call it. But that chemistry was good for engineering, pre-engineering, and pre-medical together. And so for all the engineering fields, chemical engineering, electrical engineering, mechanical engineering, civil or structural engineering, and computer science, all of them would end up doing this 103, which was a mandatory chemistry course for all the engineers and people going off into medicine. So at first I had registered into the pre-medical arena, and then I later on, because of financial reason, I switched over to engineering, seeing that I had to work, and I said if I had to do medicine, I would have to adapt my mind 100% to doing medicine. But doing engineering, that was to work. I worked 8 hours per day and come to school doing a full credit load, and so that showed up on my my grades. You know, when I'm supposed to be getting A's, I end up with C plus and B's because I had to work. I've been in classes coming in from a 12 to 8 shift and from 11 to 7 shift, graveyard shift and all of that I work, and then come into class and falling asleep while the professor is giving his lecture. I got an A for the course anyhow. But let's get into it without any further ado. So I'm starting off here with the percentage of S&P character in SP3 hybridization. So we have now the percentage of S and P, spin and principal, character in SP. This is really SP1, but they just, the SP1, SP2, and SP3 hybridization. They just call SP1 SP. So the percentage of S&P would be in SP3 hybridization. So for SP, you have a 1 to 1. So the total parts, I'm trying to conserve paper here, would be 1 plus 1 equals 2. And therefore the percentage of S would be equal to 1 over S plus 1 equals 1 over 2 equals to 50%. Now the percentage of P will be equal to 1 over S plus 1 over 1 plus 1 equals a half equals to 50%. So we see that in SP is a 50% SP sort of spread. 50% S and 50% P. Now for SP3, we have now the ratio the total ratio and the percentage of S percentage P and so we are working out now the percentage of the S and the P in the SP, SP2, SP3 hybridization. just draw sort of a molecule here. And if we move them like that till they overlap, what we have we have less overlap. And for less overlap, we say it's weaker bonding. For the SP, more rounder there. We have more overlap. And so it's called it stronger bonding. This is the overlap here. Let's go to the bond angles. And for the bond angles here, we have SP3. The SP3 bond angle is 109.5 degrees. And for the SP2, bond angle will be 120 degrees. And for the SP, bond angle will be 180 degrees. And this means that increasing the S character result in increasing the bond angle. So right here, let's take a seat. Increasing the S character spin results in increasing the bond angles. And that the sp orbital is half a character, SP2 1/3, and the SP3 a quarter. So that now the sp orbital is 1/2 character, while the SP2 is 1/3 character, and the SP3 is 1/4 character. All right. So we're going to take a little break here, and then we'll return with some specified organic compound, their bonding and hybridization.